So this is the extension of two-force, three-force body, and composite body principles. There are problems here from level 7 to level 16. So just look at the solutions. Find the tension T in the cable when the 180 Newton force is applied to the pedal at E. Neglect friction and the weights of the parts. So we have interconnected parts. So first, let's consider this pedal, and we have normal force at C. Let's just consider this pedal. Let's denote the normal force at C as N sub C. So take note that we ignore this part first. Just concentrate on this part. Then reaction components at D, which are not important. So this angle is also 45 degrees because it is normal. N sub C is normal to this other part, and we have 45 degrees here, 45 degrees, so that's also 45 degrees with the vertical. So this distance is hypotenuse 100, opposite of 45, so sine 100 sine of 45, which I do not show here, but take note this is 100 sine 45. So moment D 0, and we have clockwise positive, so N sub C times 100 sine 45, then minus 180 times quantity 240 plus 100 sine 45. So 180 times quantity 240 plus 100 sine 45. So from there we can solve N sub C equal to 790.94 newtons. Next, we consider this other part on the left. Then by action-reaction, it is now pointing, N sub C, which is 790.94, is now pointing in the opposite directions. Then reaction components at A, we set moment A 0. So this time counterclockwise positive, so we have T times 100, then minus 790.94 times 340 to 40 plus 100. So from there we can solve the tension equal to 2689 newtons. Calculate the magnitude of the force supported by the pin at A under the action of the 1.5 kilonewton load applied to the bracket. Neglect friction in the slot. So here is the given figure. So we have a frictionless slot here. So we have NB perpendicular to the axis of the slot. Then let's extend it. If this angle is 30 degrees, then NB, the extension, makes an angle with the horizontal of also 30 degrees. So let's have the moment arm of NB, which is this. This is 150 sine of 30, so this is 75 mm. Because this is a right triangle, hypotenuse 150, and that's 30, so 75 mm. Then we set this distance is 120 cosine of 30. 120 cosine 30 is 103.92 mm. So we set MB equals 0. Then let's put the reaction components at A, horizontal and vertical. Clockwise positive, so this is equal to AV times 150. Then minus 1.5 times 103.92. So the vertical component of the pin reaction at A is 1.0392 kilonewtons. Then next we set MAR vertical equals 0. So we have AV 1.0 equals 1.092 minus the vertical component of NB is NB sine of 30. Then we can solve NB equal to 1.0392 divided by sine 30, 2.0784 kilonewtons. Then R horizontal component of the resultant is 0. So we have AH equals EH minus plus 1.5, then minus NB, which is 2.0784 cosine of 30. the horizontal component of NB is negative 2.0784 cosine 30. So AH can now be computed. It is equal to 0.2999 kilonewtons. Then the magnitude of the force supported by pin A is RA, square root of 0.2999 square plus 1.0392 square. So it is equal to 1.082 kilonewtons. The automatic drilling robot must sustain a thrust of 38 pounds at the tip of the drill bit. Determine the couple C sub A that must be developed by the electric motor to resist this thrust. So here is the given figures. We have two force bodies here, namely AD and FBE. So the forces are along this axis of the member. So let's just say FD is going to A and FBE or FE is going up. So since this is 70 degrees, this is also 70 degrees. So the perpendicular distance of FE and A is 30 sine 70. That's 30 sine 70. And by principle of transmissibility of a force, we can move the 38-pound force here at C. Then let's consider this CDE here. We sum up moment about D equals 0 so that we can solve for FE, or set MD equals 0. Considering counterclockwise positive, so we have FE times 30 sine 70. Then when the 38-pound force is at C, there are two components, horizontal which passes through D, so no moment, and the vertical which is 38 sine 50, and it is clockwise. So minus 38 sine 50 times 54. So from there, we can solve FE equal to 55.76 pounds. Then let's put it there. So this time, we set moment A 0. So by the way, this distance is 48 sine 70 because cosine 70 because that's 70 degrees. So that's 48 cosine 70 while the vertical distance is 48 sine 70. And these are the reaction components at A. No need to put reaction components at B because the force is the same as FE. And we just put FE here. The reaction components here by principle of transmissibility of a force is still here at E. So MA equals 0, counterclockwise positive, so equals couple at A. Then the horizontal component of 38 is 38 cosine 50. So it is minus 38 cosine 50. The moment arm is 48 sine 70. So 38 cosine 50 degrees times 48 sine 70. The vertical component is clockwise also. So minus 38 sine 50 times quantity 54 minus 48 cosine 70, the moment arm. Then plus, because this is counterclockwise, 55.76 times 30 sine 70. So this equation leaves C sub A as the only unknown using your calculator. So C sub A is equal to 623.9 pound-inch, and it is counterclockwise. A slender uniform rod of length L 50 cm is held in equilibrium as shown, with one end against a frictionless wall and the other end attached to a cord of length S 75 cm. Knowing that the weight of the rod is 45 newtons, determine letter A, the distance h, B, the tension in the cord, and letter C, the reaction at B. So here is the given figure. Note that L is given, S is given, but the angle that AB makes with horizontal is not known, so let's just call it theta. So the weight of the rod is 45 newtons. It acts as the center. So therefore, if we call this theta, The distance of 45 from the wall is half of 50, so 25 cosine theta. So this is also 25 cosine theta, the whole, while this one is length of AB 50 sine of theta. And the horizontal distance is 50 cosine theta. So let's call the tension in the cable as T, normal reaction at B as NB, perpendicular to the wall, because it is frictionless. So therefore, moment A is 0. Let's consider counterclockwise positive. So we have NB times 50 sine theta, then minus 45 times 25 cosine theta. So therefore, NB is 45 times 25 cosine theta over 50 sine theta, and that is 22.5 cotangent of theta. Next, we set MC 0 so that we involve the same terms or unknowns. So we have clockwise positive this time, so NB times H, then minus 45 times 25 cosine theta. T is not involved because it passes through C. So solving for NB is 45 times 25 cosine theta over H, and that is equal to 1125 cosine theta over H. Equating NB here with that NB there. So 1125 cosine theta over H is 22.5. Cotangent theta is cosine theta over sine theta. Canceling out cosine theta, so we have H 1125 over 22.5 cosine theta. Or sine theta is 22.5 over 1125. Sine theta is 22.5 H over 1125, so that's H over 50. So therefore, H is 50 sine theta. So this 50 sine theta here is H. That distance is H, so this is also H. So in this triangle, right triangle, because AB is 50, therefore this 50 cosine theta is square root of 50 square minus H square, because this is H from this equation. So 50 cosine theta is square root of 50 square, length of AB square minus this value, which is H, so H square. Then applying Pythagoras theorem, because S is given, 75, so 75 square equals horizontal distance, which is square root of 50 minus H square quantity square plus this total vertical distance, which is H plus H, so 2H quantity square. Simplifying, 5625 equals 50 square minus H square plus 4H square. 5625 minus 50 square is 3125 equals 3H square. So from there, we can now solve for H, square root of 3125 over 3, and that is 32.27 centimeters. Having found H, so before we can solve for T, we need to solve NB. So 50 cosine theta is equal to square root of 50 square minus H square, so that we can solve for theta. Inverse cosine of square root of 50 square minus 32.27 square over 50, 40.196 degrees. So NB is 1125 cosine of, or NB is 22.5 cotangent of 40.196. So NB is 26.63 newtons. Then if we draw the force triangle, we have vertical 45, NB 26.63, the hypotenuse is T. So therefore, T is square root of these components. Square root of NB square, square root of 26.63 square plus 45 square. So the magnitude of the tension force is 52.29 newtons. And the reaction at B is NB, and NB is 26.63 newtons. So that's it for this problem. The pipe bender consists of two groove pulleys mounted and free to turn on a fixed frame. The pipe is bent into the shape shown by a force P 300 newtons. Calculate the forces supported by the bearings of the pulleys. So here is the given figure. The reaction at A is perpendicular to the pipe, but at B it is somewhere between this point and this point because this portion is in contact with this pulley. So let's analyze the perpendicular distance. So let's form a triangle here, a right triangle. So that's NA. So this is 150 mm. Then this leg of the right triangle is 24. Radius of this pulley plus diameter of pipe 26 plus radius of this bigger pulley 42. So 24 plus 26, 50 plus 42, 92 mm. By the way, that's the reaction at B, which is somewhere between this point of contact and this point of contact, but not parallel to NA, of course. So that's 92 mm. So therefore, this perpendicular distance of NA through the center of B is square root of 150 square minus 92 square. So I will not show the calculation anymore. Use your calculator there. Square root of 150 square minus 92 square is 118.47 mm. So we set moment B0, clockwise positive. So NA times 118 equals NA times 118.47. Then minus P, which is 300 times 500. Then we can solve NA equals reaction at A, 1266 newtons. Force at A. Then we set R horizontal 0. By the way, this angle is, sine of this angle is 92 over opposite over 150. So the angle is arc sine of 92 over 150, 37.831 degrees. That's also the angle between the vertical and NA, 37.831 degrees. So R horizontal equals 0, horizontal component of resultant 0. So we have horizontal component of RBH, then minus horizontal component of NA, minus 1266 sine of 37.831. Then we can solve RBH equal to 776.48 newtons. Then RB vertical, R vertical equals 0, vertical component of resultant force 0, and that is RB vertical minus 1266 cosine of 37.831 degrees, then minus P, which is 300. Then we can now compute the vertical component of the reaction at B, 1299.92 newtons. So the magnitude, the force is square root of 776.48 square plus 1299.92 square. So the force at B is 1514 newtons. The two discs are connected by the bar AB and the smooth peg in the slot at D. Compute the magnitude of the pin reaction at A. So here is the given figure. So for the solution, take note that we have a two-force body here, which is AB. There's no force in between. So that means FA equals FB equals FAB. And since the force should oppose this couple, so it should be to the right, considering the right disc first. So because this is depressed a little, let's call the angle here as theta. The horizontal distance is radius plus radius, so 150 plus 150, 300. And because B is along this radial line, 30 degrees to the vertical, so 150 sine of 30 is 75. So 150 plus 150, 300, plus 150 sine 30, which is 75. So the whole distance, horizontal distance, is 375 mm. While the vertical distance is radius 150 minus 150 cosine of 30. This is 150 cosine 30. The vertical distance of B from E, horizontal distance here to B. The vertical distance of B from this horizontal line is 150 cosine of 30. So 150 minus 150 cosine 30, That distance there is 150 minus 150 cosine 30 or 20.096. Therefore, tangent theta of this small angle is 20.096 over 375. So theta is 3.068 degrees. So let's now apply the force Fa, which is equal to Fb. And it has two components. So reaction components at E, let's put, then because that's a pin, then Nd, because the couple is 6 Newton meter counterclockwise, so the reaction at this should oppose this, so it should be upward, so that its moment is clockwise. So clockwise moment positive, we set Me equals 0. Fa has two components, horizontal and vertical, both are clockwise. So for the horizontal component, Fa cosine of 3.068 degrees, the moment arm is 150 cosine 30, as mentioned earlier, vertical distance of B from this horizontal line. The vertical component is clockwise, so F plus Fa sine of 3.068, the moment arm is 75 mm or 150 sine 30, the 300 plus 75, this was 75. Then plus Nd times 150, then minus 6 Newton meter. To be consistent, if forces are in newtons and the moment arm mm, so we should convert this to Newton mm, 6,000 minus 6,000 Newton mm to be consistent. So combining Fa, 133.73 Fa plus 150 Nd equals 6,000. Call that equation 1. Then we now consider the left disk, and by action reaction, Nd will now be going down and Fa is pointing toward A. And component reactions at C. Considering the left disk, we set moment C equals 0. Fa has two components again, horizontal, which is counterclockwise positive this time. The vertical component passes through C, so it has no moment. So it is Fa cosine of 3.068 times 150 mm radius, then minus Nd times radius 150. So we can cancel 150, so Nd therefore is Fa cosine of 3.068. So substitute the value of Nd into equation 1, 133.73 Fa plus 150 times Fa cosine 3.068 degrees equals 6,000. So from here, we can now compute the force on pin A. So Fa is equal to 21.16 newtons. Calculate the magnitudes of the pin reactions acting on the crane at A and C due to the 5,000 pound load. So here's the given figure. So if we analyze this load here, 5,000, there are two cables, so therefore each carries 2,500. So let's just consider this cable. So we have 2,500 pounds there. Then at C, this is a two-force body. So we'll just call the force as F sub C, directed as shown. At A, we expect two component reactions, horizontal and vertical, as shown, assumed. So this is F sub C, two-force body, so it is directed from C to B and vice versa. So this angle is arctan of 18 over 48. Arctan of 18 over 48 is 20.556 degrees. So set moment A0 to solve for F sub C. Then there are two components of Fc, horizontal, which is Fc cosine of 20.556. Its moment is counterclockwise, so counterclockwise positive. The vertical component passes through A, so only the horizontal component has moment about A. So it is equal to Fc cosine of 20.556 times 18 plus 8, 26 moment arm. Then plus 2,500 times 8. Then minus 5,000. 48 plus 106 is 154. Plus, because it is at the center, plus 4, half of 8, 158. So minus 5,000 times 158. Then from there, we can solve for f sub c, 31,629 pounds, or in kips, because that's 5 significant figures already, 31.63 kips divided by 1,000 kilopounds. Next, we set our horizontal resultant component of resultant 0. So we have FC, horizontal component of FC, 31 equals 31.63 cosine of 20.556 degrees minus EH. So take note, this is in kips, so 2.5 kips minus 2.5 kips. So AH can now be computed, 27.12 kips. Then vertical component of resultant equals 0. So we have 31 AV plus 31.63 sine of 20.556 degrees, then minus 5 kips. So A vertical equals negative 6.106 kips. So meaning to say this is wrongly assigned, so it should be downward. A vertical is downward, 6.106 kips. But we are just asked to compute the magnitude. So reaction at A is square root of 27.12 kips square plus 6.106 square. So the force magnitude of the pin reaction at A is 27.8 kips. The 50 Newton force is applied to the handle of the toggle cutter. Determine the force exerted by the cutting blade CB on the workpiece E. So take note that it is the force at E which will cut the material here. And the cutter is this portion CB. The force exerted by the cutter on the workpiece E. So it's the force at E that must be computed. So let's consider the handle and A and B. And take note that we have a two-force body here, which is AD. So FA equals FD equals FAD. Let's just assign. And as shown in the figure, that's the force at A, or in this two-force body here. There are two components, horizontal and vertical. So the pin reactions at B are shown. So we set moment B0, or summation moment B0. Let's consider clockwise positive. So the horizontal component of FA is clockwise. It is FA sine 25 times 90 equals FA sine 25 degrees times 90 mm. The vertical component is counterclockwise, so minus FA cosine of 25 times 30 moment arm, the vertical component. Then minus, this is also counterclockwise, minus 50 times 120 plus 90. So minus 50 times 210. So from there, only FA is unknown. We can solve for FA. 968.06 newtons. We then consider this left portion of the connected part. This is a miscellaneous body or composite body. So FA is now acting at D, pointing D. Then this is another two-force body here. Let's just call the force here as FC. But we are talking about FE. So we remove B now. Then that's FC. So to solve for FE, it's just R of the left portion of the body, R vertical 0. Or the vertical component of the resultant is 0. So upward positive, 968.06 cosine of 25, vertical component of this, then minus FE equals 0. So from there, we can now solve for FE, 877.4 newtons. So that's it. That's as simple as that. The pump oiler is operated by pressing on the handle at D, causing the plunger to raise and force out the oil. Determine the distance D of link BC so that the horizontal pin reaction at A is 0. So here is the given figure, and we are alerted that BC is a two-force body again, so the force at B passes through C. In the same manner, the force at C passes through B. So we'll just indicate the force at B or C as FBC as shown in the figure. Then, since it is mentioned here that there's no horizontal pin reaction at A, so it's just vertical downward. So first, we set FBH R horizontal equals 0, horizontal component of the resultant force 0. So it is the horizontal component of FBC, FB equals FBC horizontal, then minus P. So that means the horizontal component of the pin force at B or at C is P. So moment B0. So take note FBCH is P. Then we set moment B0 so that we can solve AV, counterclockwise positive. So this is equal to A vertical times 35 and minus P times 70. So that means the vertical component of the reaction at A is 2P. Then the vertical component of the resultant is set to 0 again. So it is the vertical component of FBC, then minus AV, which is 2P. So that means the vertical component of force at B or C or FBC is 2P. So the angle here is theta BC. Tangent theta BC is 35 over D, and it is also equal to vertical component of FBC divided by horizontal component of FBC, which is P. So tangent theta equals 35 over D equals vertical component of FBC, which is 2P, over horizontal component of FBC, which is P. So cancel P. So that means D is 35 over 2, or D is 17.5 mm. That's it. So this is the last problem. I include this so that it will be a challenging problem. Although this is all about centroid, but the principle is still applicable here. When the C-shaped member is suspended from the edge of a frictionless table, it assumes the position shown. Use a graphical construction to find the distance x locating the center of gravity. So for this C-shaped member to be in equilibrium, the weight and the reaction here on the table, normal reaction, which is vertical, must be collinear so that it is in equilibrium. Or else, if there is moment arm, then it will rotate. So that's the idea. So if that's the weight, that's the normal. Because of the given figure, they are not aligned, but we'll just correct it because that's part of the problem to uh, test if you really know the principle here. So they should be aligned with this vertical here. And since this is 60 degrees, this edge makes an angle of 60 degrees with the horizontal, then the same edge makes 30 degrees with the vertical. 90 minus 60 is 30 degrees. So that's 30 degrees. And in this right triangle, tangent of 30 degrees is this distance here over 60. So tangent 30 is opposite over 30. Therefore, that opposite distance is 60 tangent 30, and that is 20 square root of 3 mm. Then we draw a line parallel to this edge here. And this angle is again 30 degrees. And take note that this is x. We are after for x, the location of the center of gravity. So this distance therefore is 90 plus 20 square root of 3 minus x. And this distance is 120. So tangent 30 degrees is equal to 90 plus 20 square root of 3 minus x divided by 120. So from there we can solve for x. 90 plus 20 square root of 3 minus 120 tangent 30. So x is equal to 55.36 mm. So you might say it's very simple. The solution is short, but I think if you are the ones solving this, the analysis will be long. You might not be able to analyze it in one day.